Okay, so we basically determine the operation that we perform to find a vector which is perpendicular to both vectors, and for that we have to do the cross product of the two vectors, which gives the vector which is perpendicular to both vectors. So we choose this as the answer to this question. In question 3, we determine the magnitude of the cross product between a vector and b vector. So we write the cross product of a vector and b vector, that is a cross b. And this basically is the determinant of these two vectors. So in the first row, I put the unit vectors I vector, j vector, and k vector. In the second row, I put the components of a vector, which is negative 2, 1, 1. And then in the third row of the determinant, I put the b vector components, that is 2, 1, 1. So we have to basically evaluate this determinant. And so expanding along the first row, we put this unit vector I times, we have to leave the row and column determined by this I vector. So when we leave that, we will have the 2 by 2 determinant, that is 1, 1, 1, 1. Then we put negative j vector and then multiply this with 2 by 2 determinant obtained by leaving the elements in the row and the column represented by j vector. So we will have negative 2, 1, and 2, 1. And similarly for the k component of the k vector, we leave out the row and the column represented by k vector. And so we will get this 2 by 2 determinant negative 2, 1, and 2, 1. Now let's evaluate this each of this 2 by 2 determinants. So this becomes I vector times, we multiply the product of the diagonals and then subtract with the product of the other diagonals. So 1 times 1 is 1, minus 1 times 1 is 1. Then put j vector, and here also we multiply the product of the diagonal, that is negative 2 times 1 is negative 2. We then put negative, and then 2 times 1 is 2. Then k vector, the product of the diagonal is negative 2, minus the product of other diagonal is 2 times 1 is 2. So let's see that here 1 minus 1 is 0. So this first one is 0i, minus this will be negative 4, but here we have a positive. This one here we have a negative, so this becomes positive 4j. And then this one is negative, so it is negative 4k. So this basically is the cross product of the two vectors, that is a cross b. We can also write this in component form by just including them in this bracket, that is 0 is the first component, that is I component, and 4, and then negative 4 for the k component. This one is a cross b. Now we will find the magnitude of this a cross b. So we write magnitude of a cross b, and this equals basically it is the square root of the sum of the squares of the components. The first component 0, its square is 0 square. The next component is 4, so we put its 4 square. Then the k component is negative 4, so we add its square. And so this equals 0 square is 0, 4 square is 16, and negative 4 square is also 16. And so in the next step, we write 16 plus 16 is 32. And now let's simplify this. We write 32 as 16 times of 2. That is twice of 16 is 32. And so we can write this as product of two radicals, that is square root of 16 times square root of 2. And square root of 16 is 4, and then multiplied with root 2. So therefore 4 root 2 is the magnitude of the cross product between A and B. This is this one. And so we choose this answer choice, 4 root 2. Let's do question 4. Here we calculate A cross B. So we write the cross product A cross B, and this basically equals the determinant. In the first row of the determinant, we write the unit vectors I vector, j vector, and k vector. In the second row, we put the components of a vector because we are doing a cross b. So we have to first put the components of the first vector, which is a vector. So we write 2, 7, negative 3 here. And in the third row, we put the components of the second vector in the cross product, which is p vector. So we write negative 1, 4, and 2. So we have to evaluate this determinant. Let's expand this along the first row. So I write I vector, and this has to be multiplied with the 2 by 2 determinant, leaving the row and column represented by a vector. And so when you do that, we get this 2 by 2 determinant 7, negative 3, 4, and 2. And then we put negative j vector times the 2 by 2 determinant obtained by leaving the row and column represented by j vector. So when we do that, we get 2, negative 3, and then negative 1, 2. We then put k unit vector, multiply this with the 2 by 2 determinant, that is 2, 7, negative 1, 4, when we leave the row and column represented by the k vector. Now let's evaluate this each of these 2 by 2 determinants. So here we do the product of the diagonal minus the product of the other diagonal. For each of the vectors we do like, for each of the 2 by 2 determinants we do like that. And so for this 2 by 2 determinant, 7 times 2 is 14. We then put minus 4 times negative 3 is negative 12. So this is going to be positive 12. Then negative j multiplied with 2 times 2 is 4. We then put minus negative 1 times negative 3 is positive 3. So this is 4 minus 3 plus k unit vector times 2 times 4 is 8. We put minus, and negative 1 times 7 is negative 7, but this one is going to be positive 7. And so this equals I unit vector. 14 plus 12 is 26. 4 minus 3 is 1. So we have negative. So it is negative 1 times of j. We can put negative 1. Let me write this clearly. This one is basically negative 1 j. We then have plus k. 8 plus 7 is 15. So we can write this as times 15. Or otherwise we put this in the form as 26i minus 1j plus 15k, which we write in vector component form as by writing the component using this bracket. This one is, the first one is 26, then negative 1, and for the k component it is 15. So the cross product of these two vectors is this vector 26 in the component form written as 26, negative 1, and 15. And so we choose this answer choice. This one is correct.